Hello, everyone. Welcome back to Unit 2. For Unit 2, we're going to kick it off by talking about exponent laws. So, here are three exponent laws, and I want to talk about what they mean in plain English and also why the exponent laws are true. Don't just take my word for it. I want you to understand why are these true, because if you understand why these are true, you'll never forget them. That's how it works. So, here in this one, it says that if we multiply two exponents, right? Two exponents things with the same base, right? X to the exponent m times x to the exponent n, then we add up the exponents, and it's the same as x to the m plus n. Now, why is this true? Well, let's think about it. Well, we have x to the m, which is x times x times x, blah blah blah, n times, right? And then we have times x times x times x times blah, 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 n times. So what's this all together, right? This is m plus n times in total, that these are being multiplied together, right? So that's why that law is true. Good. Okay, the next exponent law says if we have x to the power of m and then we take that number to the power of n, it's the same as multiplying our exponents, m times n. Now, why is this the case? Well, again, x to the m is just x times x times x, blah, 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 m times, and then we're doing that n times, right? So we're multiplying them together. We're taking however many m's we have, right? However many x's we have from it being raised to the power of n, and then we're doing that two more times if n is 2, or three more, right? Three times if n is 3, or four times if n is 4, and so on, right? So it's the same as just multiplying those exponents. Very good. Then we have x to the m over x to the n is x to the m minus n. And let's talk about why that is. Let's say on the top we have x times x times x, blah, blah, m times. And then here we have x times x times x times, blah, blah. We have this n times. Well, we can cancel these out. We can cancel, 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 and keep canceling until we only have however many left that we have. Right? So here, let's say m had like 10 x's, right? And this one only had 5 x's. We could cancel out 5 of these with 5 of these, and we would have 5 left, right? So we would just have x to the power of 5 remaining. It's also possible that maybe n is larger, and in that case we'll have a negative power, which just means that the value we'll have of x's multiplied together will be in the denominator and not the numerator. So that's another possibility as well. Very good. Okay. So with all of that said, let's use these exponent laws to solve some problems, because that's what we're really about today. I doubt that in grade 9 math you're going to be asked to explain why these laws are true, but what you will be asked quite a lot is to simplify using these rules. And if you understand why these rules work, then it'll be harder to get the rules mixed up. You'll think to, well, what would make sense, right? So for example, with this one, some people might get confused of, oh wait, do I add the exponents or do I multiply the exponents, right? With something like a. And you can say, well, let's see, 5 squared, that's 5 times 5, and then 5 cubed is 5 times 5 times 5 again. So that's, 5 multiplied 5 times, so it's 5 to the power 5. So if we kind of break it down and understand why the rules are the way they are, then it's less likely that we're going to get confused by the rules and accidentally do the wrong thing. Okay, and likewise, here we're multiplying two things together. So that means this is the same as 8 to the power of 9 because we're adding the exponents. As for C, this is the same as 7 to the power of 10 over 7 to the power of 4, which is 7 to the power of 10 minus 4, which is 7 to the power of 6. Very good. Awesome. The next one is 3 to the power of 8 over 3 to the power of 2, which is 3 to the power of 6, right? Because we're going to subtract them, right? We're going to do 8 minus 2, which is 6. Over here, we're going to multiply the exponents. So this is going to be 4 to the power of 27. And same with this last one, 10 to the power of 4, because we're going to multiply the 2 and the 2. Okay, now let's write each of these as a single power. So number 2 is the same as number 1, except rather than having actual numbers, we're just going to have variables to work with. So here we have some base b squared times the same base to the power of 8. Well, that's going to be b to the power of 10, right? Because we're adding the exponents. Good. Then we have y to the power of 5 times y squared, which is y to the power of 7. Then here we have w to the power of 6 over w to the power of 3. And so we subtract our exponents and we get w to the power of 3 as our final answer. For this next one, we subtract the exponents as well. So we get x to the 4 minus 3, which is x to the power of 1, which is just x. And then over here, we multiply our exponents. So n squared to the power of 4 would be n to the power of 8. And likewise, this would be c to the power of 15, since 5 times 3 is 15. All right, let's move on to number 3. It says use the exponent rule to simplify, then use a calculator to evaluate. So this is different from number 1 in that here they just wanted it as a single power. Now they actually want us to evaluate. So there will be a third step here where we put it into our calculator and find out what the answer is. But we can't just directly put it in our calculator. They want us to use the exponent rules to simplify first. So make sure on a test that you don't just put the answer if it asks you to use exponent rules to simplify first, because they, in order to get full marks, they may want to see both steps done. Okay. Now that said, you can just punch these numbers in your calculator to check your answer because it should be the same if done properly. Okay. Let's try A. This is 2 squared times 2 to the power of 5. So that's going to be 2 to the power of 7, which then let's type that in our calculator. What is 2 to the power of 7? Is 2. That is going to be 128. Is going to be the answer. Okay. All right, the next one is 5 to the power of 1 times 5 to the power of 2. Well, that's the same as 5 to the power of 3, which is 125. So there's that one. Then we have 4 squared times 4 cubed, which is 4 to the power of 5. Which is 1024. Then we have 6 to the power of 5 divided by 6 squared, which is the same as 6 cubed, right? Because we subtract those exponents. 5 minus 2 gives us 3. And then 6 times 6 times 6, or 6 cubed, I believe is 216. All right, and over here we'll have 10 cubed because 8 minus 5 is 3, and that is 1,000. Good. And then here we have 11 to the power of 7 minus 4, which is 3. So that's going to be 1,331. Good. All right, and then for this one we have 5 to the power of 6, which let's see what that is. That would be, oh, that's a big number. That's 15,625. And then here we have 2 to the power of 5 times 4, which is 20. So that's another big one. 2 to the power of 20 is 1,048,576. Well, that's a really big number. That's a lot. Awesome. Okay. This next part is some thinking and inquiry with these. They want us to find the value of the unknown exponent. So the way to think of these ones is just to kind of turn it into some algebra based on what we know, right? For the first one, it says 2 to the power of 3 times 2 to the power of 5 is 2 to the power of what? Well, we know that when we multiply with the same base, we add our exponents. So x would be 8. We would just add the exponents there. Awesome. For the second one, b, let's see, it would be, we would be adding 6 to y, right? We know that 6 plus y would have to be 7, right? Because we would add the exponents to get that third exponent because the bases are all the same. So therefore, y would just be 1, right? 6 plus 1 is 7. Well, 6 plus 1 is 7. So there we go. Then for this one, we could say, well, k plus 2 would have to give us 8. So therefore, k would be equal to 6. Good. And then we have D, which is, let's see, M plus 3 would give us 9. And so M would be 6. So there we go. Awesome. Okay. All right. The next one says determine the unknown exponent. So this is actually this is really the same as before because determine the unknown exponent and find the value of the unknown exponent. It's really just a wording difference, it looks like. All right, so for this first one, we have to add 6 and 7 to get the exponent y. So that's going to be 13. For the second one, it's going to be, let's see, 3 minus x would have to give us 1. So x would be 2. And then for, let's see, this one, it would be m minus 2 would have to give us 6. So therefore, m would be 8. And then here, k minus 3 would have to give us 5. So k would once again, or I guess the last one was m, not k, but the answer once again for the unknown exponent would be 8. Very good. All right, let's determine the unknown exponent now. In this case, w would have to be 6 times 7, which is 42. In the second example, 2 times y would have to be 8. So therefore, y would be equal to 4. And then here we would have 4 times x would be 12. And so x would be 3. And then for D, 5 times y would be equal to 15. So y would be equal to 3. Very good. Okay, so these ones are a little bit harder because these are multi-step problems. We're not going to do this. We're just going to end it after 10. So for this one, the first thing we must do is we must multiply these two exponents, the 3 and the 2, to get that this is 2 to the power of 6 divided by 2 to the power of 5. And then we would do 6 minus 5, which would give us 1. So this would just end up being 2. Good. Same with problem B. First we need to add the first two exponents to get 6 to the power of 9 divided by 6 to the power of 7. And that would be 6 squared, which is 36. So the answer for B would be 36. All right, for C, the first thing we must do is multiply, right? So x to the power of 10 times x to the power of 3. So that would be x to the power of 30. And because x is a variable, not a number, we actually can't simplify that further because x is an unknown to us. And so we can stop there in that case. For D, we have y squared times y to the 4, which is where we would add. So we would get y to the power of 6 over y to the 6, which this simplifies to 1. In this case, we could simplify it to a number because even though y is an unknown, whenever we have the same number twice, even if that's an unknown number, as long as y does not equal to 0, then this will always be 1, right? Assuming y is not 0, then this is always going to be true. Good. All right, for this next one, we could say k to the power of 5 over k to the power of 4, because we multiply those 2's, and then we just end up with k as our answer. And then over here, we have n to the 21 over n to the 15, which is n to the 6. And there we go. Good. Okay. The next one is 9. It says -2 squared. Well, let's think about that. -2 squared is -2 times -2. So that would be +4. What about -2 to the power of 5? Well, this would be -32 because we're taking it to an odd exponent, and so the answer can be negative. Whenever we're raising a negative number to an even exponent, well, that means that we're going to end up with a positive value because every two negatives make a positive. So whenever we have an even number that we're multiplying, right? If we're multiplying an even number of times, then every number has a pair and there's nothing left out. Whereas it's the opposite is true when we're raising something to an odd power. If we're raising a negative number to an odd power, then a bunch of them will be able to pair up and make positives, but there will be one odd one out, right? There will be one odd one out that makes the entire answer a negative answer. All right, what about this one here? This would be the same as -2 to the power of 7, right? Which that is a negative, that is an odd one as well. So that would be a negative answer, and that would be -128. Good. All right, so the next one is we're dividing, so we're going to subtract. So therefore, we have -2 cubed. So what's -2 cubed? Well, that would be -8, right? Because again, it's an odd power, so we're going to end up with a negative answer, right? The first two -2's multiplied would give us +4, but then as soon as we multiply that +4 by -2, we're back in the negative. We're back to -8. Okay. The next one is -3 cubed squared, so that would be the same as -3 to the power of 6. So that would be 729. And since we're raising it to an odd power, an even power, we're going to get something positive there. And if we think about it, let's say we raised it to the power of 3 and then to the power of 2, we would still get something positive, right? Because first we would get something negative after we took it to the power of 3, which is an odd power. And then after we square it, right, if we square anything, we always get a positive or 0 answer. We never get a negative answer by squaring something, regardless of what that something is, right? And so that's going to make good sense. All right, and then this one here, we have -2 to the power of 10. And then on the bottom, the thing is, -4 is not the same. Right? Yeah, no, -4 is not the same, unfortunately. Sometimes it's possible to switch bases, to switch a base, but in this case, -4 is just not the same. So I'm going to evaluate these separately. So first we have negative 2 to the power of 10, which gives us 1024. And then on the bottom we have 64, or negative 64 rather. And so our answer is going to be negative 16. Good. All right, and here they're asking us to evaluate each power. So negative 2 cubed, well, that's just going to be negative 8. We actually already answered that up here in D, so they kind of asked the same question again. And then here they have negative 2 to the 0 and negative 10 to the 0. Now keep in mind, anything to the power of 0 equals 1. So regardless if it's a negative number, a positive number, whatever, anything to the power of 0 equals 1, right? It's a universal truth that x to the power of 0 equals 1, regardless of what x is. Good. All right, so that is everything for today. Good work, everyone, and we'll see you for the next day. Bye, everyone.